Okay, so there are many variations with the following graphs. I will give you some variations of some of them and then just go through and show you the bits and pieces that are important to identify so that you can double check whether or not what you drew was actually correct. Alright, so let's start with a quadratic function. We know a quadratic function is a parabola, and a parabola can not touch the x-axis. It can touch the x-axis once, or it can even touch the x-axis twice. We know that it can also be inverted, and this was from transformations that we've learned before. Again, touching it no times, it could touch it once, or again, it could touch it twice with two x-intercepts. So, let's see what stipulations this one states exactly. We need two non-real zeros. These non-real zeros mean that we know it's a quadratic, so it will be x squared of some kind. But the non-real part is saying that it will not actually touch the x-axis, so there will be no x-intercepts. So you could draw something that looks like this, or you could draw something that was negative that looked like this. Okay, either one on that one. Let's do the next one. So we have a cubic function, which we know is x cubed of some kind, with one real zero and two non-reals. So you're going to have one x-intercept, and then this one does not, so no x-intercepts when they're non-real solutions. Okay, so cubic. Again, this one did not say a negative cubic function, nor did it say a positive cubic function. So you could have two variations, one that kind of went up as you went to the right, or one that went down as you went to infinity, as x approached infinity. So let's go ahead and do one that is positive this time. So we're going to say it is a cubic function. Because of the fact that this 3 is here, we know there could be up to 2 bins. Okay, it doesn't have to be 2 bins, and that's not the rule of what we learned with like x to the 4th, x squared, or x to the 6th. There are times that it doesn't have to necessarily have that n minus 1 number of bins. But let's also look at the fact that it is an odd number. So what we talked about from the previous part of the unit is that because it's odd, as you go to negative infinity, it will have this odd symmetry about it in some respect. Alright, so we have one x-intercept, and we have no x-intercepts for these two non-real pieces here. Okay, so two non-real pieces and one real piece adds up to the total of 3. And that tells us that this one real piece cannot not be a double root. Because if it was a double root, otherwise something that bounced off the x-axis, that would be counted as 2 real zeros rather than the one that it's saying that we need. So we know we're going to not bounce, but we're going to go through the x somewhere around here. 2 non-real zeros means that the bends will still occur, but they do not actually touch the x-axis. So color coordinating, these bends really never come down and touch the x-axis, but this one real zero actually does, and just has that multiplicity of 1. So this could be something that looks like our graph. Alright, number 7 is looking for a quartic, so it's 4th degree, with 3 changes of direction possible, and it says with 2 real zeros and 2 real non-zeros. So these 2 real zeros are basically saying we will have 2 x-intercepts, and then where these bends occur, there would not be, so not have 2 x-intercepts, but still showing the bend. So let's make this a negative quartic. Again, this is just varying it up, kind of giving you the different types of answers that you could have. Let's say that it was a negative quartic. Okay, so it would go down as you went to positive infinity. Alright, because of the fact that this is x to the 4th, that even number says as you would go to negative infinity, it too would go down. Again, remembering that even powers have this even representation. Now we just need to show that there are 2 x-intercepts, 3 change the direction, and not have these x-intercepts. So only 2 x-intercepts with 3 changes of direction. So I could go 1 change of direction, 2 change of direction, but I could not go all the way back up to the x-axis because I cannot have those 2 non-real solutions show up. So that's kind of like where that piece would be located, but where these 2 real solutions we're looking to show, those x-intercepts would occur there. So I can double check it by seeing it is to the power of 4. We do have 2 real solutions, 2 non-real, and it is an even function in that respect. As far as I go to the right and left, they both dip down to negative infinity. So a quartic function, this is again x to the 4th, but we have one real double root. Okay, so this double root, by words we know it's going to bounce. So bounce off x-axis, and it has 2 non-reals. So one double is like x squared, and 2 non-reals is in the x squared, so the total would be my x to the 4th. We just have to show a power of 4 with 3 possible changes of direction, and then the following that we highlighted. Okay, so let's make this one positive. So as we go to the right, it will go up to infinity. Because of the fact that this was an even number, okay, we know that as we go to the left, we will also go to positive infinity. Now we just have to show 1 bounce, 3 changes of direction, and that's it. No other x-intercepts, because those 2 non-real zeros that we were talking about, it cannot actually touch the x-axis. Okay, so let me highlight that real quick. These 2 non-real zeros will show the bend here in just a bit. So let's bounce 1 time. Oops, let me get that red. And then we're going to show the 3 changes of direction. So we're going to bounce off the x-axis and then show 2 more changes of direction. Let me highlight these as we go. 3 changes of direction shown here, here, and here. 1 double root is shown right here because it bounced. And then finally, these 2 non-real could be interpreted as being somewhere here. And those are just some examples, and yours can vary a little bit depending upon the stipulations are satisfied, but those are some examples of how these 4 could work.